Example 9 says solve for x. So this looks very similar to an equation we looked at in the last section when we talked about exponential functions, and that was the one where I found that the base was the same, right? But if you look at this, that fun little trick isn't going to work because we have two prime numbers, right? There's no way I'm going to find any 5s inside of the 2, and there's no way I'm going to find any 2s inside of the 5. So you're going to have to use logs because that's the only way we're going to be able to get these exponents out of, or these variables, excuse me, out of the exponent. So we could use log base 2, but that's not really going to help you with the 5. We could use log base 5 on this side, but that's not going to help you with the 2, and it's a lot of extra writing. So generally in math, we tend to, when we kind of get to pick any log we want and there's no real clear path to make it easier, we just usually use natural log. It's easier to write, you don't have to worry about the base. So what I'm going to do is I'm going to take the natural log of both sides. So the natural log of 2 to the x equals the natural log of 5 to the 4x plus 3. Then the properties of logs say that I'm allowed to pull the exponent down front. So it's x natural log of 2. And for this one, be careful because I'm not just pulling down an x, I'm pulling down in an entire expression. So I have to use parentheses and I have to make sure that this whole thing gets multiplied by the natural log of 5 because the 5 was raised to all of it. Then it's just algebra from here to solve for x, but in order to get this x out from inside these parentheses, I need to actually distribute this natural log of 5. So x natural log of 2 equals 4x natural log of 5 plus 3 natural log of 5. We're going to put everything with an x on one side of the equation, so I'm just going to move it all to the left and leave everything else without an x on the right. I can factor out the x on the left side. And we get 3 natural log of 5 divided by the natural log of 2 minus 4 ln of 5. So once again, keep in mind this is an exact answer. Don't put things in your calculator around unless you are specifically told in the question what to round to. So we would just leave this as our final answer. Problem 10 is interesting because we actually have kind of 3 different very distinct paths you could take to get to the answer. So this is one of these problems where it really just kind of depends on what you see to do first. I'm actually going to show you a couple of different ways to think about this problem. So the first, we'll call this option 1. Option 1 is, I call it just let's dive into the deep end, right? So you see 2 different bases. You don't know what to do, so you're like, I'm just going to take the natural log of both sides. So if we do that, we're going to get the following. Now here's a really big, most students could get to here, right? But then this next line, this is where a lot of people mess up. So you absolutely cannot pull this x out of this equation yet because only the 5 is raised to the x, not the 2. So we need to separate this out first. And we do that if we have the natural log of 2 things being multiplied. We can say, well, it's the natural log of the first thing plus the natural log of the second thing. Now I'm allowed to pull the exponent down because it has to be the entire expression being raised to the exponent. Here it was only the 5, not the 2 being raised. So now I would have natural log of 2 plus x natural log of 5 equals x natural log of 2. I'm going to move everything with an x over to the right side. and I just went ahead and factored it out because everything over here has an x. And natural log of 2 divided by the natural log of 2 minus the natural log of 5 equals x. So this method is the same we used in the previous problem. And one thing you want to keep in mind with these two problems, right, is any log base would have done the trick, right? Natural log just meant a lot less writing for me, so that's why I picked that one. So there's another way you could do this problem. So let's call this option 2. Well, if I write this equation out, I see a lot of 2's. I see 2's on the left and I see 2's on the right. Oh, sorry. I said that wrong. I see x's in the exponent, okay? So if you have two different numbers being raised to the x, if you know your properties of exponents, and this is where I said you need to know how to combine things and split them apart. Well, one of the properties right here said if you have two different numbers raised to the same exponent, right, you can split them apart, or we could combine them together. So let's take everything that's raised to the x and put it on one side of the equation. So 2 equals 2 to the x divided by 5 to the x. That is the same thing as saying 2/5 raised to the x. So now I still need to get this x out of the exponent. If I take the natural log of both sides, I get x natural log of 2/5, right? Because as soon as I take the natural log, I can pull the x down front. And now natural log of 2 divided by natural log of 2/5 equals x. So if you actually type these into your calculator and do a decimal approximation, you will see these are equivalent answers. A third option that we could do is we could start with the original equation, and you might see I have 2's on both sides, so I want to combine the 2's. So you can say, well, 5 to the x equals 2 to the x over 2. Well, this is really 2 to the 1. So if you go back and look at your exponent rules, if you have the same base over the same base, you can combine them by taking the numerator minus the exponent in the denominator. So that means this is the same thing as 2 to the x minus 1. So if I take the natural log of both sides now, then I get x natural log of 5 equals x minus 1 natural log of 2. I'm going to distribute the natural log of 2 on the right side, and I'm going to put everything with an x on the left. So I'll get x times natural log of 5 minus natural log of 2 equals negative natural log of 2. So x equals negative natural log of 2 over the natural log of 5 minus the natural log of 2. Now, this looks very close to this answer. The only difference is the sign of the numerators is different and the order of subtraction is different. So if I multiply this by negative 1 over negative 1, not necessary, this is a perfectly fine final answer, this ends up becoming positive natural log of 2 over natural log of 2 minus natural log of 5. So you can really easily here see that this was an alternative way to get the exact same answer we got before. So if we typed either one of these in our calculators, right, we would see that these are equivalent answers. So on the answer key to the practice on your own, you'll notice that some of the answers, I give them in multiple ways, because depending on how this was 3 very different paths to get to the answer. You want to make sure that you're comfortable when you do log problems, that as long as you take a correct algebra path to get to the answer, your answer may look visibly very different depending on what base you took than the answer key says. And so it's sometimes good for practice to use a decimal approximation to make sure they're equivalent answers. But on the exam, we would use these exact answers. So those were only really provided for you so you would feel comfortable when you do this algebra and you look at a crazy answer like this and you'd be like, well, I know I did it right, okay?